Hello everyone, my name is Ayush Mishra. Welcome again to my channel as Tuber. I hope you guys are healthy and happy. In the previous session, I talked about blockchain, what is block and its content. We also implemented a sample blockchain application using Rust. In this video, we will continue working with our sample blockchain application that we built in the last video. I would give some overview of blockchain validation and its mining process in this video. Let's take a look at the blockchain validation. So why do we need it? Because we have to ensure no one can tamper any data in any of the blocks in the blockchain. We will be considering two things for blockchain verification. We will recalculate the hash of each block and compare it with original hash. If there is any mismatch, we can flag it. We will also compare previous block hash with the registered previous hash. We will do this for all the blocks in the chain to ensure that the full chain is valid. So let's try to implement it. So here is the blockchain file. Let's add a function. So we'll add a function is valid chain. As this is for validation, so return type would be boolean. As I mentioned, we have to do this for each block in the blockchain. So let's add the for loop, which will be executed for all the blocks. So we are adding a first condition where we'll be matching the current hash. We'll first recalculate the hash and then we will compare it with the current hash of the block. Now let us add the second condition in which so in this second condition, as I mentioned, we'll be comparing the previous hash of the block with the hash of the previous block, and make sure you are not adding this condition for the genesis block, because genesis blocks will not have the previous hash value. They will have the default values. So let's call this method in our main program before printing the blockchain. So currently it is returning true. So now let's tamper the data. I'm going to set a previous some random string to the previous hash. Now if I run this program, it should return false. Here it is. So this was about the blockchain verification. Now let's take a look what is blockchain mining. Till now we can create blocks very quickly. All we have to do is just to create a transaction, compute the hash and add in the blockchain. People can create billions of blocks in seconds, but that's not we want because they can spam our blockchain or attack on our blockchain. There is also a security issue. You can change content of blocks and recalculate hashes of all blocks, and finally you end up with a valid blockchain. It is difficult, but yeah, it is still possible. So this is not we want. To solve this security issue, blockchain has something called proof of work. With this process, you have to prove that you have put lot of computing power into making a block. So this process is called mining. What it does basically, it alters first leading characters of hash to zeros. That is called difficulty level. It is the number of zeros we want as leading characters in hash. So we will add new value nonce in block with initial value 0. While computing hash, we will keep increasing this nonce value by 1 until hash leading character match with the difficult level. So this is all about blockchain mining. I won't go into the deeper for this concept, but like I think we have talked enough. Let's do some coding for the blockchain mining. So as I mentioned, let's introduce first a variable nonce in our block struct. Now we have to make corresponding changes on every places. We also need to add one more parameter in the calculate hash function. Because we also want to include nonce in the while calculating hash. Okay, let's make the changes here as well. Now we have to set difficulty level. We will be setting in the library file. let's make it as constant. We need a method in library file to get the target string, basically since we have set a difficult level, so we need a string with the leading characters of zeros. I will name it as a get difficult string. Now we need a function in the block to mine the block to start the mining process. So in this while loop, we are matching like whether the leading characters of the current of the hash of a block is matching with our target string. As I mentioned, we will keep increasing the nonce value. And we will keep recalculating hash until we get the leading characters as 0 in the prefix section of the hash. now we have added a mine function in block. So in the blockchain file, before adding the block, we have to call this method, because once the mining process is done, then only the block can be added in the blockchain. I think we are done. Okay, so we also need to pass nonce here. Okay, let's try. Cool, we get error. Okay, oops. Here we go. So let me show you the output. So we added 3 blocks, and for those 3 blocks we got this message block mine. Our blockchain is valid, so that's why we get the true message here. And now if we see the blockchain, the hash of the genesis block is start with the two leading zeros, since like we have set the difficult level as 2. Now if we go to the first block, this previous block is previous hash is matching with the hash of the previous block, and the hash of first block is also start with the two leading zeros. The hash of second block is also starting with the two zeros. So we have successfully mined our blocks, and we have successfully completed the mining process. So guys, this is all about in this session. Thank you for watching the video. Thank you.